Hello, I welcome you all to this another interesting screencast. The problem reads the ship travels at a constant speed of Vs equal to 20 meters per second, and the wind is blowing at a speed of Vw equal to 10 meters per second is shown. Determine the magnitude and direction of the horizontal component of the velocity of the smoke coming from the smokestack as it appears to the passenger on the ship. This particular problem is coming from the Engineering Mechanics Dynamics 14th edition by R.C. Hibbeler. So let's define what we have. Let's start with the subscripts. So let's say S, of course, is for the ship as given already. W is for the wind. Then let's say SM is for the smoke. What else? P for passenger. Alright. So we are being asked here to determine the magnitude and direction of the horizontal component of velocity. I'm not sure why they mentioned horizontal, because I will have both horizontal and vertical component, right? And then we use that to find the magnitude and direction. Okay, so I will say determine the magnitude and direction of the smoke coming from the smokestack as it appears to the passenger on the ship. I'll just read it like that. So this the velocity, okay, of the smoke with respect to the passenger. Okay, let me just make mention the velocity, okay, of the speed of the passenger on the ship will be equal to the speed of the ship. Okay, therefore the velocity of the smoke with respect to the passenger on the ship is just equal to the velocity of the smoke with respect to the ship. Okay, and then the velocity of the smoke, the speed of the smoke, okay, when this particular ship is just stationary, not moving, will be equal to the velocity of the wind, okay, which is equal to 10 meters per second. Okay, this one is equal to 20 meters per second. Okay, so with this we can therefore rewrite this and say velocity of the smoke with respect to the ship is just going to be equal to velocity of the smoke minus velocity of, these as vectors now, okay, velocity of the ship. Okay, so let's write down the components. So we'll have components for this particular speed, okay, for the wind, which is equal to velocity over the smoke. Okay, that is as observed or with respect to the earth. Okay, so what do we have here? This one is a 20 cos 45, and this one is a 20 sine 45. This one is a 10 cos 30, and this one is a 10 sine 30. Right, so there we go. We have this like so. So for this component for smoke, like we said, this is just equal to V wind minus V ship. Okay, so the V wind, there we go, This is 10 cos, and let me make mention of our reference system. This is our reference. Okay, those are the positive x and positive y. So this is 10 cos 30 I minus 10 sine 30 j, then minus there vs. We have a 20 cos 45 I, and then plus a 20 sine 45 j. Okay, so what do we have? Let's sum them up. So we have a 10 cos 13 minus 20 cos 45. A 10 cos 13, okay, minus 20 cos 45. Okay, so this we get a minus 5.4819 I, and then we have a minus 10 sine 30, which is just minus 5, and minus 20 sine 45. So this we get a minus 19.1421 J. Okay, all right, so there we are. So we can find the magnitude. So magnitude of this, which is just equal to BSM, like so. We put it in this modulus, so this just becomes square root. So we know here to say our x component, our VSM component, let me just write them. SM x is minus 5.4819, and our VSM stroke SY component is equal to minus 19.1421. So putting them in here, okay, x squared plus VSM stroke SY squared. We have our VSM stroke S equal to 5.4819 squared plus 19.1421 squared. In the square root of that, we have a 19.91 meters per second. So let's find the angle. This is just going to be equal to tan inverse of VSM SY divided by VSM SX. Mind you, what we have here is they are both negative, so we have one component in this direction like this, then we have another component in this direction like this, then we have the resultant. The resultant will be closer to the bigger one, bigger value, which is closer to the y, like so. Okay, right. And then we have this angle here. We have this angle here. This is the angle that we are looking at, right? This is our VSM stroke SY. This is our VSM stroke SX. Okay, so there we are. So therefore theta, plugging in those values in there, theta becomes equal to 19 point, the minus, of course, minuses will cancel, 1421 divided by 5.4819. Then tan inverse of that, we have a 74. We have a 74.02 degrees. Okay, let me check it again. 19.1421 divided by 5.4819. Okay, let me just write down to say this one here, it is the magnitude SM stroke S, like so. All right, so let me outline the final solution. We are done. So we found the magnitude and the direction of the velocity of the smoke coming from the smoke stack as it appears to the passenger on the ship. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.